welcome you all to another Hertfordshire Building Control CPD webinar. I'm Trevor Clements. As most of you probably know, I'm Head of Business Development. A little while ago, I did a webinar on problem soil conditions, and I touched on the subject of contaminated land. And, you know, building control people, we're a bit of a jack of all trades in some ways, and I couldn't delve too deeply in that subject. So today I'm delighted to be joined by a company called STM Environmental. I came across them because they do a lot of work with local authorities on contaminated land, and one of their things they do is provide a sort of GIS database that they can delve into when they're doing their environmental searches for properties and land. And yeah, I happened to speak to the gentleman who's going to lead off today, who is Simon McConey. He's one of their STM's environmental engineers, and in fact he's a director of the company. And he's going to be supported by Lara Griffin and Kelly Swanner. As we've done in the past, which seems to work well, we're going to keep people on mute so we don't get too much background. But if you've got burning questions, there's a chat button. Put them on the chat button, and then if we've got time at the end, I will go through those questions and ask the panel to answer them. So without further ado, I'll stop wittering on and I'll hand over to Simon to take away the first part of the presentation.
Great, thank you, Trevor. Hopefully you can all see my screen at the moment.
Yes, we can.
Welcome to this introduction to contaminated land. Thank you for attending, and thank you, Trevor, for inviting us to undertake this with you. It's a great pleasure. So what I'm going to start off by doing is just giving you an overview of the presentation. I'm going to talk a little bit about who we are, who STM are, give you a bit of background, policy and legislation, just to give you get you grounded in the sort of contaminated land, the purposes for what we do. Then we're going to go through how we do a contaminated land risk assessment. So that's going from the phase 1 desktop study through into the phase 2 site intrusive investigation, where we you know, take soil samples and so on. And then the phase 3, you know, if the site investigation shows there's a need for some sort of remediation, i.e. there's contamination at the site, you go into a phase 3 remediation process. And so we're going to go through all of those. So yeah, who are we at STM? So I'm, as Trevor mentioned, an environmental engineer. I've sort of been doing this for about 29 years. I was shocked when I started counting the other day. So 29 years, 12 of which were in local authority as a contaminated land officer. So I jumped ship about, probably sort of 15 years ago, 16 years ago, and started STM Environmental Consultants back in 2004. We, as Trevor said, we work a lot with local authorities. We initially started off basically sort of with a bit of software, a GIS and database management solution, which we managed to get into over 75 local authorities. So the contaminated land officers use that software to manage all their information about on contaminated land sites, potentially contaminated land sites, I should say. So that was the mainstay of the business for many, many years. And then we started sort of branching out into doing the actual consultancy work on behalf of private sector developers. And so we now do, you know, we're specialists in contaminated land, but we also do geotechnical investigations, flood risk assessments, surface water drainage strategies, air quality, you can see the list, noise, etc. So basically anything to do with planning and environment, you know, where we're usually able to help. So that's who we are. Let's get into the background on contaminated land. Why are we here? Essentially, the whole thing is driven by this housing need that's been identified, critical housing need. there's 4.7 million houses that we need to satisfy demand. And that equates to about 300,000 houses per year for the next 15 years. So that's a lot of houses. Where to build them? We're on an island, so limited space. We also have a commitment to sustainability, which means we want to protect our green spaces. We don't want to just encroach on the countryside, because then we're also going to decimate our wildlife. So that led the government to sort of have a little think and decide, well, actually, we've got all this brownfield land, we've got this amazing industrial legacy of all of the sort of industrial sites that have now shut down. We could use those sites to build the houses. So that's what, when we talk about brownfield land, that's what we're talking about, previously developed land. Now, there's a study carried out recently which found essentially there's approximately 26,000 hectares of land currently available. And all this has been added to what are known as brownfield registers. So the government came up with a regulation requiring local authorities to basically publish lists of previously used land that they consider would be suitable for housing developments. And so, yeah, 18,000 of these sites are currently available, and we'll cater for 1 million of those 4.7 million homes. So we're making good progress. The government, it has a target for the percentage of housing that's going to be built on brownfield sites, and I think it was 60% initially, but it's been exceeded, and we're getting sort of 80% of houses being built on brownfield land. Obviously there's the contamination element associated with that, so and that needs to be dealt with. So in terms of legislation, you have the European directives that give us the overriding framework, and I won't go into those into detail, but you can see some of them there. In terms of policy, we have the MPPPF. Everybody knows about that, I'm sure. Essentially, the driving idea behind that is that sites should be suitable for the proposed end use, and that needs to take into account contamination. At the very minimum, after remediation, a site not be capable of being determined as contaminated land under Part 2A, and I'll come back to Part 2A a little bit later. Very specific legislation for dealing with contaminated land. Just on that note, as a minimum, it shouldn't be capable of being determined as contaminated land, but generally under planning, you go for much higher standards for housing developments. Okay, so how do we enforce the policy? That's through primarily the Town and Country Planning Act 1990, which essentially requires developers to demonstrate to the local authority that they've addressed all the matters that are material adequately, and contaminated land is a material concern. The Building Regs 2000 and Approved Document C provide a lot of guidance on how you should be dealing with contaminated land sites when developing for houses. Then we've got specific legislation that's designed to enable authorities to deal with actual contamination that's occurring, ongoing contamination. So you have the Part 2A, which I touched upon earlier, Part 2A of the Environmental Protection Act. Essentially that's to deal with, gives authorities powers to go in and serve notices, requiring people to clean up sites. So very specific. The Water Resources Act gives the Environment Agency powers to enforce decontamination of sites that are polluting controlled waters. So that would be groundwaters or surface waters. You have the Wildlife and Countryside Act 1981, which basically protects ecological protection zones and various other bits of legislation which so there is quite a vast framework of legislation controlling contaminated land. As I say, Part 2A is probably the main one when it comes to housing and how you develop houses. So if you've developed a house and you've left the contamination in situ, local authority comes along and says, well, let's take a few samples here, and they find the site to be contaminated. They could then serve a notice and require remediation of that site. Now, in order for a site to be contaminated, it's not enough just to have contamination in the soil. You have to have what's known as a pollutant linkage, which requires a source, pathway, and receptor. And Lara will go into that a little bit further later on. But just the idea of you have to have significant possibility of significant harm before the land can be contaminated. So yeah, if you just keep that in mind, you have to not just have contamination, you have to have a way that that contamination can impact the environment or humans. And so when you're thinking about that, the conceptual site risk model is very useful. So, when you're looking at contamination in the soil, you've got to be thinking about, how can that impact my future occupiers of this development? When they're playing in the gardens, the kids are, rolling around in the soil, etc., inadvertently ingesting and inhaling dusts and so on. If you've got ecological zones nearby, that contamination could be destroying, flora and fauna. Potentially, if you've got buried waste on the site, you could be generating gases which are migrating up into your house, and if they make their way into a confined space, you could get an explosive mixture, which could cause an explosion. You've got contamination that can leach down into the water table, into the groundwater aquifer, not only polluting the groundwater, but also migrating and potentially causing vapors to ingress into other adjacent buildings and properties. So a lot of things to consider when you're looking at the issue of contamination. So hopefully that's given you a quick introduction, and I will now hand over to Lara, who will talk to you about phase ones and the beginning of the process of assessing contamination on the site. Thanks.
Right, well, we did have a little technical difficulty with Lara in that she'd gone offline. She's up, but she's back in because I can see her.
I'm back.
That's great. I don't have to fill in for you, Lara. I'll shut up. Crack on.
Great. Right, so can you see my screen? Perfect. So I'm Lara Griffin, and I undertake the phase 1 desktop studies at STM, and I'll now be taking you through an introduction to phase 1 desktop studies. This flowchart gives an overview of what is involved when undertaking the phase 1 desktop study. We'll go into these steps in a little bit more detail further on, but it basically shows that the purpose of a phase 1 desktop study is to decide whether any potentially significant pollutant linkages have been identified, and if so, a phase 2 site investigation will need to be undertaken. Over the next few slides, I'm going to talk you through the main aspects of a phase 1 report. Firstly, the report will need to include an introduction and a description of the site, which will usually comprise the description of the site itself and the proposed development. Then there will be a historical mapping section, which provides a chronological summary of the site and the surrounding area. The environmental characteristics section provides all relevant information of the site's environmental setting, including the obvious like geology and hydrogeology, to things like pollution incidents and landfill sites. The site walkover section provides a summary of observations made during the site walkover and photographs taken. The planning history section includes information to show previous uses of the site and also of the surrounding area, and whether there are any similar applications or site investigations undertaken in the vicinity of the site. The qualitative risk assessment and conceptual risk model bring all of this information together to decide whether further investigation is necessary. And finally, the reasons and details of this decision are then presented within the conclusions and recommendations section at the end of the Phase 1 report. Potentially contaminative land uses include the obvious, for example, petrol stations and factories, to the more complex, like rifle ranges and cemeteries. For example, pesticides can be used on allotment garden sites and agricultural land. A whole host of contaminated materials can be buried when infilling landfill sites, gravel pits, and brickfields. And fuels can be used and stored at sites like builders' yards, depots, and garages. Pollutants associated with these uses will be discussed a bit later on. In my view, the most important part of a Phase 1 desktop study is the historical mapping. These show you the history of the site and the surrounding area dating back to the 1850s, so you can get a clear image of whether there are any potential sources of contamination. A limited amount of historical mapping can be freely found available online, or you can order them through environmental websites. To give you an example of how historical maps can show the contaminative past of a site, we undertook a Phase 1 report for this site shown in the photos in 2017. This involved the demolition of some commercial buildings to be redeveloped into residential housing. This map is for the site and it's taken from 1875. If I just get up a pointer, I can show you. So as you can see, there's the boundary for the site. And you can see here that the boundary is just upon where Tower Windmill it's a flour mill. So a flour mill is considered to be a potentially contaminative land use, as it's an industrial use where they could have utilised fuels such as petrol, coal, amongst other pollutants, which obviously could have gone into the soils onto the site in question. This map is taken from 1954. You can see the site was previously occupied by a miniature rifle range as well as a laundry. Older laundries use toxic chemicals which can pollute the soils and groundwater, as well as emitting volatile organic compounds, or VOCs, into the air, which when breathed in are toxic. The ammunition used at a miniature rifle range can contain lead, and also clay targets used at miniature rifle ranges can contain polyaromatic hydrocarbons, or PAHs. Both of these can contaminate the ground, which I will discuss a bit later on. By only visiting the site and seeing how it is now, you have no idea of the previous land uses and therefore may not even consider undertaking soil sampling without looking at the historical maps. Phase 1 desktop studies also contain information on the environmental characteristics of a site. For example, historical landfill sites, the EA hold information on current and historical landfill sites. If not managed correctly, these can lead to contamination of soils and build-up of explosive gases such as methane and carbon dioxide. Brit Pits is a database held by the British Geological Society of current and closed surface and underground mineral workings such as clay pits. Similar to landfill sites, if these are infilled with contaminative materials, they can give rise to gases. Part B activities are regulated under the environmental permitting regulations for the release of substances into the environment. For example, laundries will require a Part B permit in order to operate. Environmental characteristics also include more generic information like the geology, hydrogeology, and topography of a site. Another important part of the report is searching the planning portal. By looking at the site's planning history, as well as the surrounding areas, you can get further information of past uses, as well as looking into whether any site investigations have been undertaken within the vicinity of the site. If this is the case, you can utilise information taken from the Phase 2 report to support your argument. For example, say the site next door have identified a ground gas risk, it may be at risk at your site as well. If you require more information, you can also apply for an environmental information request or contact the council's contaminated land officer for more information. A site walkover can also sometimes be undertaken as part of the report. When visiting the site, it's important to take lots of photos which can then be utilised later in the report. Sources of potential contamination are noted down like asbestos-containing materials, for example garage roofing. The ground cover, building cover and drainage features are also observed as, for example, if there is concrete covering the site but it is in poor condition with lots of cracks, then pollutants could have reached the soils beneath. There are many different pollutants which can cause soil contamination, groundwater contamination and also ground gases. For example, methane and carbon dioxide are ground gases which can cause explosions. Heavy metals like lead can be toxic when ingested, and fuels and fuel oils can contaminate the groundwater by leaching through the soils towards the water table. All of these pollutants can have a very harmful effect when ingested or breathed in. Kelly will explain this a little bit more later on. These are the most sensitive receptors of contaminated land. For example, human health receptors include both users of the site and neighbouring sites, which could be harmed if there is contamination present. Ground workers are also included in this, as they may be exposed to contaminated soils during development. Building and services can be impacted by contaminated land if there is a high level of sulphate in the soil. These can lead to erosion of pipes, and ground gases can build up and lead to explosions. The next two slides show how contamination within the soils can impact these receptors. This is called a pollutant linkage, which involves the source, the pathway, and the receptor. In this diagram, you can see that there is a contamination source which is able to get to the sensitive receptor as they are growing vegetables which they will then eat. Therefore, the source is the waste, the pathway is the vegetable, and the receptor is the little girl. Whereas in this diagram, although the source is still there and the receptor is still there, there is no longer a pathway present as the site is occupied by a building, so the receptor is no longer in direct contact with the soils. This is obviously a simplified version of how the source pathway receptor concept works. For example, if there was a ground gas risk present at the site, the building would not break the pathway to the receptor, and ground gas protection measures would need to be incorporated into the foundation design. All the information collated as part of the Phase 1 desktop study leads into whether there is a potential risk at the site, and therefore whether further investigation is required. To get to this conclusion, a qualitative risk assessment is undertaken. I've broken this down into some key elements. Firstly, the contamination risk matrix shows how the risk increases when the probable likelihood of contamination being present is combined with the potential severity of the outcome of this. So basically, if a petrol station was being redeveloped into residential housing with gardens, the likelihood of the contamination would be probable or frequent, and the severity of this could be major or fatal. So then the risk would be high or very high, depending on the type of development. The contamination matrix leads on to the conceptual risk model, which classifies the risk into levels depending on the combination of these outcomes. This table shows a simplified version, and if I take, for example, on-site human health, this would be the occupiers of the residential dwellings. The potential pathway could be by ingestion or build-up of methanes or VOCs, which can cause explosions for methane or can be harmful if breathed in VOCs. And then the potential the potential hazard would be some health issues, death or explosion causing death, and therefore the risk would be very high. PSPPL stands for potentially significant potential pollutant linkage, which basically means there is a potential for the source pathway receptor to be complete. Finally, this is the more in-depth version of the conceptual risk model. It draws together all of the information from the Phase 1 desktop study in one place. There will usually be a section leading on from this, which outlines the reasoning why a Phase 2 is required, or why one is not considered to be necessary. So as you can see, you've got everything in one place. You've got the source, which includes the potentially contaminative land uses, the potential contaminants associated with the land uses, and then you've also got the receptors broken down into each category, so human health, groundwater, surface water, and buildings and services. potential hazards, and then the risk assessment is down here. So for example, severity is major because it's human health, the likelihood is possible because of the potential uses, and then the outcome for the risk is moderate. So there is a potentially significant potential pollutant linkage. I hope this gives you an overview of what is included in a phase 1 desktop study and why they are so important, not only in deciding whether a phase 2 investigation is required, but also in identifying the potentially contaminated land uses so the investigation can be as successful as possible. So I'll now pass you over to Kelly, who will be introducing the phase 2 site investigations.
I hope everyone can see my screen. Yeah, okay, thanks for that, Lara. Yeah, I'm Kelly Swanner, and I mainly undertake the phase 2 contaminated land investigation reports. And so here is a brief overview of what I'll be talking about today. Firstly, what is a phase 2? Following on from what Lara said, designing a site investigation and actually undertaking the investigation, different methodologies, different types of drill rigs, the generic quantitative risk assessment or GQRA and generic assessment criteria or GAC. I'll come back into detail about all of these a bit later on. Receiving the lab results and statistical analysis procedures, reassessment of the potential pollutant linkages that were identified in the phase 1. Finally, concluding, is remediation necessary based on the findings of the site investigation? And then I'll be tying this all in together following on from the case study that Lara previously discussed. So firstly, what is a phase 2? It's important to define the objectives of the investigation. What is it that you're trying to achieve or prove or disprove about potential contamination on the site? Then design the investigation based on these objectives and the initial conceptual model from the phase 1 desk study. It's important to continue going back to the conceptual model in the desk study to see if the site investigation sufficiently allows for sufficient investigation, and continue with the investigation if this is suitable. And once the investigation has been undertaken, see if there are generic assessment criteria available. So I'll summarise this, but I'll go into this a bit later. The GAC is a value of a specific contaminant, which lets you know if the identified levels of the contaminant are suitable and acceptable for the proposed end use of the site. If no GACs are available, then a detailed quantitative risk assessment is necessary. I'm not really going to get into this, unfortunately there's no time for that today. So then going back to evaluating the risk, once the investigation results are back, and decide if there are any acceptable or unacceptable risks, if there were exceedances of contaminants, potential toxic contaminants identified, and if there were no unacceptable risks identified, then no further action is recommended, or we would then progress to phase 3 remediation, which Simon will be talking about a little bit later on. So designing a site investigation. The investigation is designed based on the findings of the phase 1, which is why it is so important to undertake the phase 1 first. Otherwise, you'll never really know the requirements of the scope of the investigation, or the history of the site and what contaminants you should potentially be looking for. When deciding on the number and the locations of the boreholes, you want to try and get a good coverage of the site, as well as target any sensitive areas, such as proposed gardens or soft landscape areas, or any known potential sources of contamination, such as tanks or underground storage tanks, fuel tanks, that type of thing. How many soil samples will be collected? We usually collect 2 from each borehole, one from the top 500 millimetres or so, possibly from the made ground, which is where you would think that you would find most of the contamination, if there is any, and then one from the underlying natural strata. And we prefer to take a few extra samples, just in case there's a requirement to get more tested at a later stage. So this then saves the consultant having to go back to the site unnecessarily. Is there a requirement for ground gas and vapour monitoring, as well as groundwater monitoring? This is all decided based on the findings of the desk study and if there are any potential risks that were identified in the desk study. And also, will a geotechnical investigation be undertaken at the same time? This is, again, usually preferred by the consultant and the client, as it saves the client a bit of money, getting the consultant out to the site only once instead of twice, and saves the consultant time. I'm going to talk you through a couple of different methods of undertaking site investigations. Firstly, this is a Dando Terrier dynamic windowless sampler rig. As you can see, it is fairly small and compact as drill rigs go. When in transit, this shaft here is actually lying down. So it's about 2 meters long by about 1 meter wide, and it's on this track. So it is actually able to move, it's quite flexible and able to move through fairly small spaces, such as a standard doorway. Depending on the geology, this type of rig is suitable for reaching depths of approximately 10 meters. So that's a good one. This is a cable percussion rig, slightly larger than the dynamic windowless sampler. This type of rig is suitable for reaching much deeper depths. So if it's a larger building with deeper foundations needed, then you'll probably need a cable percussion rig. As you can see, it does take up a lot more space, and getting it to the site is a little bit more tricky than the dynamic windowless sampler. This is an example of soil profile, a soil profile encountered. The borehole was approximately 4 or 5 meters deep, and this shows you, the picture shows you how the strata is changing every meter or meter and a half or so. And it's a good example of how much the underlying geology can change in fairly shallow depths. And lastly, this is a hand auger, a very simple but effective contraption, very useful for sites with limited access. On the right here is an example of some soils encountered, or the soil profile encountered using about 1.5 meters or so of an extendable hand auger. Very useful. Earlier, I briefly touched on the generic assessment criteria, or the GAC. So just to remind you, the GAC is a value of a specific contaminant which lets you know if the identified concentrations of that contaminant are suitable and acceptable for the proposed end use. I'm going to use lead as an example and show you all the various GACs available for lead depending on the proposed end use. As Lara touched on, if lead is ingested, it's highly toxic in many ways, and we want to try and avoid it at all costs. So, for example, in an allotment, the highest acceptable level of lead, or concentration of lead, is 80 milligrams per kilogram. Moving on, so this would be the most sensitive to the least sensitive proposed end use here. Moving on to a residential with garden land use scenario, and therefore, if you've got a private garden, then maybe the possibility for you to grow your own home produce, children playing, that type of thing. The highest acceptable concentration of lead would be 200 milligrams per kilogram, so slightly higher than what would be allowed for an allotment. And then moving on to a residential without gardens, so more like a communal land space in a block of flats. Still the possibility for children to be playing there, but unlikely to be growing any homegrown produce. So the allowable highest acceptable concentration of lead is slightly higher at 310 milligrams per kilogram, and so on as you go towards these, lesser sensitive proposed end uses. When the results of the soil samples are received from the lab, these are checked through to identify any exceedances, if any exceedances above the chosen GAC have been identified. If there are exceedances above the acceptable GAC concentrations, the location of these exceedances are then analysed, i.e. are they widespread throughout the site? Are they in multiple boreholes at multiple depths? Or are they sort of concentrated into one or two locations or at particular depths only? This is then followed by undertaking statistical analysis. Unfortunately, or fortunately, depending on how you look at it, I don't have time to get into much detail regarding the complete statistical analysis procedures undertaken. But in summary, we specifically look at the mean value tests and the Chebyshev test to see if the exceedances identified are in fact located in what we would call a hotspot, or if they're a bit more widespread throughout the site. The conceptual risk model in the phase 1 DEST study is then reassessed with the information that we've gained from the site investigation. So was contamination identified? Was it in sensitive areas such as proposed gardens or soft landscaping? Or is the site going to be covered entirely in permanent concrete or the building footprint, for example? Based on this, we then decide if remediation is necessary. So now to just put this all in a bit of perspective, I'm going to come back to the case study that Lara spoke about earlier. So because of the potential risks identified that Lara spoke about earlier, the site was previously a flour mill, a laundry, and a miniature rifle range. And the proposed development was to redevelop the site from commercial to residential with private gardens, so possibly one of the most sensitive end uses. Naturally, an intrusive site investigation was recommended and then undertaken. So this map shows the borehole locations. So there are 5 here, and the locations were decided based on the access, so building access, building coverage of the site. This part of the site was inaccessible, unfortunately, as well as down here. So, and this part of the site is where the proposed gardens will be or are now for the proposed development. So we did our best in getting a good coverage of the site, as well as putting some boreholes in the most sensitive areas. So these are some photos of the soils that were encountered during the investigation. You can see there's quite a lot of made ground, and by that I mean the bricks and rubble, and basically you can tell that this has not naturally been put here, so there could be some potential contaminants in there, just all around sort of nasty looking soils. This is an example of a trial pit or borehole log that was taken from one of the boreholes undertaken at the site. You can see that the made ground extends to 1.3 meters below ground level, and this is then underlain by the natural chalk strata that was encountered to the depth to the end of the borehole at 1.7 meters. This table shows the contaminants which were identified that exceeded the chosen GAC of residential with plant uptake. So because the proposed end use was to have houses with private gardens. You can see the GAC values here. Note the lead 200, which I spoke about earlier, and the other GAC values along here. And this column shows the maximum identified concentrations. And you can see that some of them significantly exceed the GAC 10 times more even. And then in this column, if you think back to the borehole location map that I showed you earlier, there were 5 boreholes. So this column shows the exceedances, borehole locations where the exceedances were identified. And you can see that exceedances were identified in all 5 boreholes. So it was concluded that it was fairly widespread and in multiple depths, over multiple depths. Oh, sorry, asbestos. It's not shown here, but 5 of the samples also contain trace amounts of asbestos, and one is slightly more than just trace amounts. So to be sure, the client asked us to go back and check this and collect more samples. And unfortunately, we found even more asbestos positive samples, and Simon will speak a bit more about that later. Potentially significant potential pollutant linkages were identified as part of the DEST study, which were mainly concerned with the direct contact and inhalation risks to the on-site human health receptors, as well as potential damage to the proposed properties and associated services included in the proposed development. Based on the results of the site investigation, PPL1A and PPL5A were all the PPLs were re-evaluated, and PPL1A and PPL5A were still considered to have the potential to be significant. Therefore, some sort of remediation was recommended. So now I'm going to pass you back to Simon, who's going to continue, or he's going to explain the remediation process and then continue with the case study.
Hopefully you are all seeing my screen now. Lovely. Lovely. Thank you for a lovely explanation of phase 1s and phase 2s. So phase 3, so basically you've gone through the process and you've decided, unfortunately, yeah, that there is contamination at this site. We need to do something about it. So then the next step is planning your remediation. So this is a little summary of the various steps involved. So you need to define your objectives. What are we trying to achieve, first of all? Once you've figured that out, go into how can we achieve the objective? What options do we have? Determine a strategy. One of the things you have to do usually to sort of discharge a commencement condition, planning condition, is submit a remediation strategy to the local planning authority. So key part of the remediation. Implement the works and determine whether or not you need to do long-term monitoring, if there's ground gases involved, kind of thing. Verify that works have been successful and have been carried out according to your plan, and then that final report again to discharge the occupation condition, usually of a planning condition. Okay, so defining your objectives. Let's go back to that conceptual model, all the different ways in which receptors can be impacted by contamination. We need to decide what are we actually concerned about, and that's, Kelly touched on that in that phase 2 reassessment of the potential pollutant linkages. You decide what your objective is. You want to break the pollutant linkages that are considered to still have the potential to be significant. So that could be, if you're worried about ground gas ingress into the properties, then you need to do something to prevent that from happening. If you're worried about people, children playing in the garden and so on, eating contaminated soil, yeah, you need to break that pathway, that possibility. Groundwater leaching into the contaminants leaching into the groundwater. How do we prevent that from happening? So to define your objectives first of all. You then look at the options you have to deal with those pollutant linkages. So in this case, if we're worried about direct contact and inhalation in gardens and houses, we've got a number of ways we could deal with that. We could encapsulate the contaminated areas by building car parks or just completely covering it with concrete. That would solve the problem. Not a very nice end result though for someone who's going to live there if the whole development is just concrete. So not the most desirable option, but it will work. You could extract and excavate all the contaminated soil, take it all off to landfill. It is feasible, you could do that. Most cases it's not, it's not cost effective. It's extremely expensive to deposit contaminated soil in landfills. And it's also not very sustainable. There's a limited as I said earlier, there's limited land available, and we don't want to keep building landfills for contaminated soil. Typically, what happens is you build a clean cover system. So you might excavate some of the contaminated soil and replace it with clean topsoil, leaving a kind of a barrier to prevent people from digging into the contaminated areas. And for ground gases, you'd be looking at installing gas protection measures. Okay, so options appraisals, lots of different ways you can deal with contamination depending on what type of contamination it is. They're broadly split into physical techniques, chemical techniques, and biological techniques. So for physical techniques, you have, as I mentioned earlier, maybe an engineered cover system to contain contamination, make it inaccessible, barriers, excuse me. This is a pleasure of working from home. Physical approaches to deal with things like dual phase extraction, to deal with contaminants in groundwater. Dual phase extraction involves essentially pumping groundwater out of the ground, treating it and disposing of it into a sewer. Air sparging, soil vapor extraction, and soil washing, basically essentially cleaning the soil. So digging it out, cleaning it, and putting it back. You've got thermal approaches, which include sort of essentially heating the soil to evaporate any contaminants. You've got chemical techniques, which involve essentially the addition of some sort of chemical to the soil to break down the contaminants or to solidify and stabilize the soil so that the contaminants they're not mobile, they don't leach away into the groundwater. Biological techniques, probably arguably the most sustainable, where you're using microorganisms to break down contamination naturally. Problem with those techniques is that you need quite a lot of time. So yeah, if you've got a big site and you're not in a hurry to develop it, let the microorganisms loose onto it. Okay. I mentioned remediation strategies a little bit earlier. So you need to produce a report. Once you've worked out what you're going to do, how you're going to do it, produce the strategy, and send that into the local planning authority. And if they're happy with that, they will allow you to start the development. And typically, your strategy needs to detail, the remedial works you're going to carry out, how you're going to verify that those works have been carried out. Very important part of it, timescales, etc. So once you've implemented the works, as I mentioned earlier, you need to typically submit a verification report to the local authority, explaining and detailing everything that's been done on the site, basically proving that you've done what you've said you were going to do. So that includes, photographs, lots and lots of photographs of the works, duty of care paperwork, so that's things like waste consignment notes, just to prove that soil actually has been taken away. You'd be surprised the sorts of tricks some builders try to pull. So it's very important to keep your waste consignment notes, just as I say, to prove you've excavated and removed the soil that you said you would. Any soil sampling certificates. One of the things people do a lot when they import clean soil onto a site, they put it down, they maybe get a certificate from the supplier saying it's clean, and they just go with that, put it down, and then later find out actually it was contaminated, that soil that I bought in, that clean soil. So you need to do your own testing. Don't just trust the supplier. Typically, soil suppliers, they will take one sample you know, sort of from a massive stockpile, you know, which could be maybe over, you know, sort of probably one sample per 200 cubic meter of soil, which is completely useless. So you do need to do your own validation sampling for imported topsoil. Yeah, so essentially get all that evidence together that the works have been done and successfully treated the potential pollutant linkage. So yeah, just going back into our case study. In that case, as Kelly mentioned, we had the two potential pollutant linkages. One was concerned with direct contact and inhalation. So we had lead and all these nasty PAHs and even asbestos identified at the site. At the time, we only found trace concentrations of asbestos, but we were in for a little surprise, but I'll go into that a little bit later. So this was the options appraisal, where essentially we're looking at how we're going to deal with this this contamination we've identified, and we've come up with an engineered capping layer, option 3, which would essentially involve excavating 600 millimeters of the contaminated soils. You know, we've proven the made ground went down to 1.3 meters, so 600 mil was only some of it, but then we'll build that with a barrier and some clean topsoil. And it was going to be communal soft landscaping, so you know, it wasn't going to be private gardens where people could maybe start growing their own vegetables and that kind of thing. So we've figured that would be okay. We also then the is just ensuring that the service trenches that they're, you know, sort of in clean trenches and lined trenches. So that was quite simple. So yeah, again, with the site, there were quite a few challenges in terms of remediation. You can see it was a built-up residential area. You know, just simply things like parking. You need to be very well prepared. Make sure you get your parking permit, because it's going to take a few weeks normally. In this particular case, the access to the site was very limited. We had this little gate, which basically, you know, couldn't drive any sort of big equipment into. So we had that limitation. So difficult trying to excavate soil and move it in and out and that kind of thing. The site was also sloping, so very, very difficult in terms of, you know, trying to work out levels and that kind of thing. So we had to get our GPSs and everything down on site. Yeah, so a lot of challenges with this site. But yeah, we got stuck in, bought mini diggers and so forth. Now we had obviously the suspected asbestos that we had encountered in the phase 2. So we were all sort of prepared for the worst, and you know, everybody was updated on their asbestos awareness training and everything like that. You know, as soon as we started excavating, we started realizing, actually, this is not just a case of trace amounts of asbestos here. We've got quite a big problem. And you can see here, it's difficult to kind of show it in a photo, but you know, as we were excavating, we were coming across like fibrous stuff and lots of you know, just basically fill. Essentially, what had transpired was that the site had been used as a builder's yard for a number of years, and that wasn't apparent from the historical maps. So for some years, builders used it and basically just dumped everything they could onto the land, and then left it, covered it with some soil and left it. That includes asbestos. So there's quite a lot of asbestos on the site. You know, and that gave us lots of other problems. We then had to get in a licensed asbestos contractor. We had to manage the neighbours who were, you know, understandably very, very worried about all this work excavation going on in their backyard. We had to bring in air quality monitoring just to make sure we weren't releasing asbestos fibres into the air. You know, that was done by continuously damping down the soils as we were excavating. Yeah, just being very, very careful, and obviously protecting our own health and safety at the same time as we were removing all this soil. And as you can see, they're very difficult with the access restrictions as well. We had to bag the soil and then sort of cart it out onto the road, where we then got a licensed tipper to come and pick it up. So yeah, it's very interesting case. Eventually, once we'd cleaned up all the, dug down to the necessary levels, it was then building it back up. At this point, we handed back over to the developer's builder, who we left in the instructions, basically build the site back up. And these are photos of clean soil being laid on top of a geotextile membrane. Now, these photos were sent to us sometime after this work was done. So when we went back eventually to double check that they'd done the backfill in the way that we'd specified, we found actually that they hadn't. They'd laid, I won't go into the details of it, but essentially they hadn't done it properly. And so we had to sort of have a prolonged discussion and explanation of why it was important that they should do it properly. Essentially, they'd laid this. It's amazing. They'd laid this the geotextile in clean topsoil, and then later on, they had some more waste soils, which they dug up somewhere else on the site, which they then probably decided to lay on top of the clean topsoil. And so when we came back to take validation samples, and them to be contaminated, and so they had to strip that contaminated soil back again, put clean topsoil on, and eventually everything was satisfactory. But this is how the site looked at the end. Very nice development, beautiful views, and hopefully a safe and clean environment for people that are going to be living there. So thank you for your time, and I'll hand back over to Trevor, just in case you've got any questions.
Trevor, you're muted. Sorry, you're muted, Trevor.
That's funny. I unmuted and sometimes it muted me again. There we go. Anyway, I'm back in the room. And what I said was, while you couldn't hear me, was thanks to Simon, Kelly and Lara. Fantastic. You absolutely nailed that brief. And it was very, very interesting presentation. Love the use of the case study, particularly one that was so interesting. And, it brought out to me that, your profession, you come under the same pressures that we do. You've got to be professional, and sometimes you've got to give a customer bad news and advise them to spend a lot, they need to spend money. And then, you've got to do that in a sensitive way, because, we're a service of choice, and there's commercial competition there. So good on you for being totally professional and making sure that that site was absolutely clean and fit for habitation. There's a few questions here. I did say, if anybody had any burning questions, to put them on chat. So if you don't mind, if I put them to you, first from Peter Moore, a colleague of mine actually, can you, let me just see, sorry, he's just clicked down, they're all coming in now, thick and fast. Can you give us an idea of the costs and timescales involved with each phase, please?
Should I take that?
Okay.
Yeah, so essentially your phase one, it's a size we have for that. So you're looking at around £550 plus the VAT for the phase one. And that covers the acquiring of historical mapping as well. So there's the historical maps that Lara showed. There's a couple of companies that supply those, dating all the way back to the 1880s actually, to current day, which give us a good sort of indication of what happened on the site and in the surrounding areas. So that is included in the price. The phase 2 is really there's no standard price for that. It depends on what the on the site and the potential issues that are there. If it's a simple sort of go down, take some soil samples and assess, you could be looking at anything from about 1,500. But if ground gas monitoring is required and groundwater analysis and that kind of thing, the costs can go up. And it depends on the size of the site, of course. The bigger the site, the more the samples you need to take. And so, yeah, it really does depend on the site. And remediation, again, it depends on the problems you're trying to resolve.
Okay, thank you for that. Hopefully that gave the answer. Lots of thanks and praise coming in for the presentation. A question from Angela, who says, do the soil pollutants affect pets and farm animals in the same way as they do humans, which is an interesting one. Don't know if somebody wants to take that.
Kelly, do you want to take that one? Okay. Sorry, Kelly.
Kelly doesn't want to take it.
I'm muted. You can take it. You're on a roll already, so carry on.
Sure. Yeah, I mean, essentially, yes. I think humans, animals, kind of, we would react the same to contaminants. A lot of the Kelly was talking about GACs before, generic assessment criteria. They're concentrations that have been determined to be safe for humans and in the different land use scenarios. So those GACs have been arrived at based on toxicity studies, which typically are undertaken in animals. So there's an explanation to humans from them. Hopefully that answers you.
Okay, thank you for that. I think that's it for questions. Somebody's, Paul has said, is it possible to get a copy of the slides? Well, we've done a recording of this, so there will be a recording available of the whole presentation. Yeah, Paul, I guess, Simon, would you be able to provide us with your slides that we could maybe put a link to on our website for anybody who's interested?
Yeah.
Excellent. Well, that's a yes to that, Paul. So we've got a couple more messages just in case there's any questions. One more then, are remediation certificates issued to the client developer as a matter of course? That's from Chris.
So remediation certificates, there's no such thing really as a certificate, but what you get is a remediation report, a verification report. I guess you could call it a certificate. But yeah, we would typically issue that to the developer, to the client, who would then typically, if there's a planning condition, send that into the planning authority and to building control as well. So the remediation verification report is essentially your certificate.
Okay, right, well that concludes the questions and concludes the webinar. Thanks again to the presenters, Simon, Kelly and Lara. I really thought that was very interesting and enjoyable. So yeah, watch this space. Hertfordshire Building Control will continue to put on the CPD events for you to hook into, and yeah, we'll be in touch. So take care, everybody, and Simon, Kelly, and I will maybe speak to you in a bit, and we'll talk. We'll have a bit of a washdown. Thanks very much, and bye for now.
Thank you, everybody.
Cheers.